Oh, thank you.
Nice to meet you too.
You have a figure on the seat?
I do. Oh, awesome. Thank you.
So, I think there's a new release point about the lost by this person and slide the cool. Let me check if it is. Hello?
No pizza for you?
I stayed for
Breakfast? 11?
No, we had executive personal committee.
Really? What does that committee do?
All the
Oh, the reviews? Wait, those aren't due yet, right?
No, this is the faculty.
Every faculty has to get reviewed every year?
So we did that. So we deserve free breakfast.
Yeah, that's fair. Okay, this is good.
That's why I ate too much.
Say what?
And I ate too much.
So, let me try
Hey! For EV, it was in here for like one semester, like maybe a year and a half ago. EV was a good one. Not this room,
This room.
but downstairs in one of the auditoriums.
I depend.
Really?
There's a lot of
That's cool. I've been in this room once for like some like meeting I was invited to about education in Africa, but that's it.
There's an actually
It was like a bunch of different, all these different apartments that are building this library.
and it's on engineering. Education's on that.
Yeah, that she must have been there. Yeah, she might have been one of the main people. There was like a couple doctors presenting and random people, but I think I remember her being there. I didn't even realize that engineering education was something you could major in.
It's a graduate.
Oh, that's so cool.
How long? Doesn't work. Maybe you have to use the platform or the cable.
Oh, that's okay. Yeah, no problem. Work.
So do you have yeah, the head doesn't work, so yeah, we use it to do that. The headless should be a command that's pre-installed. Yeah, and the command the C have all these general options. So what are you changing? So I'm finding that you go to like
clear alpha pipe that.
oh yeah. No, it's not wrong. It works. Oh, maybe. Okay.
Hey,
Good luck.
thanks. So questions might be calling for you.
Yeah, I'll be prepared.
Okay, cool. Josh, did you know Lucas? Okay. He's one of the undergrads that's working on this project.
I was gonna say, so you can say candidate now.
I changed it.
Yeah, he was.
I was wondering.
So actually I added it before I just had my name.
Yeah,
But
he was like.
I was telling Brandon, the way mechanical does things, you get
Let's say what?
the way mechanical does things, you can't say candidate until 6 months pretty much.
Yeah.
Yeah, that's right.
Bio's so different.
I think your prelim's more stressful.
That's what I thought.
I don't know. You're a qualifier though.
They split it up, I guess, for us. I'm looking forward to seeing this stuff because I heard a lot about it. I haven't actually seen.
This is like very biological in
That's okay.
focus though. Not nearly as much engineering. Mostly
That's okay.
why tracking technology is good.
Because I just heard bits about the engineering side, but not.
Lucas will be able to talk more about that because he's the genius behind it.
Okay. Well, I did the Lemur solar head already, so he does have one. I'm just gonna take that to China.
Okay, I'll even look at it and see what he didn't get back to me before. I am.
I know you worked it, right?
I know you. Yeah, I just actually finished my application today.
How long would you was being there?
8 weeks. So we're leaving June 1st.
The United States did not actually expert.
Yeah.
I changed it.
You will enjoy it.
I hope so. It should be good.
Are you going to China?
Maybe not. Maybe not this year. Not this year.
No, are you gonna stay here Blackbird?
Yeah, I might be staying here. They're doing it in China. Yeah, it's good. I'm excited. I've never been, so I don't spend all of my time working. It's so different. Yeah, it is. I'm sure.
So you're saying America is very different from China?
Yeah.
Interesting.
I believe it.
I'm just soaking up. I don't know. It's still waiting. A lot of people like I don't set up applications or listening applications for like contact community. Yeah, and like my I don't know.
It's not, I mean, I would say the presentation was like 20 or 25 minutes. So.
He wants me to meet Friday and see how that goes. So, I have no clue whatsoever.
Hey! Yeah, it's crazy. Glad we don't have to make anything too small. Yeah. You're right.
You don't know Christine was one of the students of ours.
Really?
It's so. What's Christine doing?
Alex, we have a doppelganger.
Oh yes, yeah, Kelly told me.
Yeah.
Yeah, I think up to 5 seats. Yeah, that's something like.
No.
You know. There's.
We can kill it. What I call it. Yeah, I mean, should I clean the flag?
Oh, sorry, people.
Yeah.
So big tables for each. That sounds fun.
They're guinea fowl that have been brought over from East Africa. They're not native, but they live pretty much across the island. There's a store called Rural King. Yeah, they sell chicks. They're really cute. They're really cute. They're very
I stopped there.
How do you keep them from not just like going miles away?
Oh, it's true. I know.
Yeah, they eat them a lot of
It's just gonna be more work.
Working with it's just a project.
They don't scratch.
Yeah.
Yeah.
I've been telling you.
Yeah, definitely still working. No, because they're really just having been
Last year,
doing much of
Yep.
introduce you.
Okay, real quick, I don't care.
Here's Meredith. Hey, Meredith.
Hey.
She's a graduate student in biological sciences, and she's going to talk about a project that she's been working on, trying to develop tracking technology for animals.
So my talk is pretty biological in nature. Towards the end, it will get more into the engineering. But I'm going to talk to you guys about the benefits of using tracking technology to study wildlife. So these pictures here show the breadth of what you can do with tracking technology. You can track things as small as a stink bug up to the size of a large whale species. So technology now allows us to be able to look at these things on a great scale. So many decades ago, really any time before 25 years ago, typically studying wildlife was done with what we call a boots and binoculars approach, which in essence means that if you wanted to study wildlife, you had to put on your boots, take out your binoculars, and study wildlife completely based on observation. This is really time consuming. You can also change the animal's behavior by being present in their area. It's also difficult due to some animals being nocturnal and active at night, others being active randomly. So being able to just study animals based on observation can be quite difficult. So over the last 25 years, tracking technology has gotten more and more advanced. Those are normally grouped into two categories as either being VHF or very high frequency, or GPS, or a combination of the two. VHF tracking collars just have a radio chip in them, and so you're able to track wildlife through that. So you would need some sort of antenna, like the picture up here. Essentially, you have a directional antenna. You point it in a direction and listen for the strength of the beeping sound, and that can tell you the general vicinity of where the animal is. GPS is more advanced. You're actually getting a location of where the animal is at set intervals. So these types of tracking devices can fall into different types. So you can have collars. The difficulty with collars is that the animal's head circumference has to be smaller than or larger than its neck circumference, which is not the case for all animals. You can also have harnesses, which are usually used with large birds, where there's actually a harness that goes around their wings, and they almost have a backpack with the tracker. You can also have glue-on trackers, which is what this tortoise has, glued onto the top of its shell. You can have implants, whether that's ingested or in the birth canal of an animal. And you can also have ear tags. This is commonly used sometimes in cows or moose or different large antelope species. So you can track something as large as a moose and animals that live on land, such as wolves or wild dogs in mainland Africa. Marine species you can track as well, like this whale shark and seal. Avian species, you can have tags on their legs or tags that are glued onto their back, as well as backpacks like I was tracking on this bald eagle, as well as tracking invertebrates. So you can track really small wildlife because the size of the tracking technology has decreased greatly. You can also have implants. So this is actually an implant that would go into the birth canal, generally of antelope species. And I'll talk more about this later of what this can actually be used for and what sorts of data can be used. And then lastly, an implant can be used like in the snake where it could be ingested and you could gain data on its movement until it passes it in its stool. So why would we remotely track wildlife? So I'm going to go into some of these in more detail, but we can track their ranging behavior, look at different types of social behavior, generally any sort of movement data we can gain. And so the reason that we can try and do this, which is very pertinent now, is being able to look at global changes, which are impacting wildlife species across the globe. Particularly for my study, I'm interested in how habitat loss influences all these different variables here. So ranging behavior is one thing I'm particularly interested in, and what that really means is daily path length. So it's how far an animal is traveling per day. So this bush baby on the left may only move 200 or 300 meters a day or a night because they're nocturnal, whereas a wild dog can move upwards of 35 miles per day. So being able to have tracking technology can enable you to learn about their daily movements. You can also study something called dispersal, and this is the movement of animals from the group that they're born into when they leave and they try and find a new group to join once they reach adulthood. So something like this snow leopard or a puma could move hundreds of miles once they reach adult status in order to find a mate or another individual, and chimps on the right are also known to do the same thing. They can move upwards of 60 miles in order to join a new group. So dispersal is something that wildlife biologists are very intrigued with, and we don't know much about it. How far animals travel and how long are they by themselves before they find a new group. So by having tracking collars particularly, we can answer these kinds of questions in very cryptic species. We can also study social proximity, especially in social species such as dolphins or elephants, where they live in tight-knit family groups. So what you could do is you could go in and you could tag certain individuals from the group, and you could look and be able to make social networks and be able to understand how their social proximity influences their survival or different facets of their biology. You can also study home range sizes. So an animal like a polar bear, its overall range where it could move throughout its life is larger than the state of Mississippi. So if you can imagine an animal that can move hundreds and hundreds of kilometers throughout its life, so we can understand why is it having to travel so far, where is it going, to allow us to better protect the species. We can also, something like this hare may only move in several hectares, or I mean, sometimes their home range could be the size of this room. So a species like that, if we don't know how far it's roaming, it can be difficult to protect. Migration is also something that's important. This is an Arctic tern, and they have the longest migration distance of any bird. And humpback whales also have very long migration distances. So by putting trackers on these animals, we can understand how far they're moving, if it's kind of a stop and go like behavior, once again, so we can better protect them. Some animals also engage in what's known as cooperative hunting. And so that is when they come together as a group to be able to take down larger prey items, such as these wolves hunting elk in Yellowstone. So by putting tracking collars on wolves or elk, we can understand how the wolves are coming together in order to take down these prey. Do they play specific roles within the group? How often are they hunting? You can also do the same thing for prides of lions that are taking down large prey. So we could ask lots of questions about coalitions and overall organized hunting. So there was a study done recently in moose, and they inserted these implants into the birth canal because there was a study looking at birth sites in moose, so trying to figure out where are the young actually born. And so when you insert these transmitters, when the calf is born, the transmitter falls out and gives a GPS signal, so scientists can actually go and locate where the birth site was to be able to understand how that's happening. And you can also track the animal during that time. One thing I'm particularly interested in looking at is preferred habitat. So many animals could have many different habitat types within their home range, whether it be grassland or savanna, forest, or swampland. And so by having tracking technology on an animal, you could determine which of these habitat types is it spending the majority of its time. That way you can protect that particular habitat type more closely than you would another habitat type. And lastly, you can ask questions about hibernation. So this is a dwarf lemur here, found only on Madagascar, and they live in really high elevation forests. And even though Madagascar is an island, it actually gets very cold in certain parts. So this species is known to hibernate for 4 to 6 months out of the year. So you can put collars or different tracking devices on them to be able to determine how long they're hibernating, as well as where they're hibernating, so you can study them during that period of time. You can also add sensors to tracking technology, whether that be temperature, so you could measure the either external or internal temperature of an animal, oxygen sensors, which can be used especially in studies of hibernation, light, which can be measured to see if they're spending more time maybe at the top of a canopy or within the forest. Accelerometers to measure locomotion, to look and see, try and see where animals are moving and at what rate, as well as heart rate monitors. Mostly heart rate monitors are used in some cases to look at stress physiology. So animals who are more stressed generally have higher heart rates, so you can try and look at that. So challenges of tracking technology. So I'll pass this around. This is an example of a traditional tracking collar. This is a GPS collar that was used to track foxes in New York by another grad student here at Virginia Tech. A GPS collar like this cost about $2,600 for this piece, so they're incredibly expensive. So you guys can pass it around and have a look at what a GPS collar for a small mammal would look like. So generally the cost is going to range between $2,000 and $3,000 for a collar that will last roughly 1 year in battery life. The weight is a really big issue. When you're tracking wildlife, generally you cannot put more than 5% of their body weight on them. So if you're studying an animal like that dwarf lemur, they weigh less than 100 grams. So if you're trying to track them, the largest size collar you can put on them is only 5 grams. So that's a huge issue. So these are examples of commercial tracking collars like this one that's being passed around that can be used on small mammals. And as you can see, the weight ranges from roughly 10 to 110 grams. So you can track wildlife that are roughly at least a kilo or more in size. But anything smaller can be very difficult.
Question.
Yes.
You said you can't put something on those more than 5%. What is it? What do you mean by that?
So generally speaking, with small mammals, the max amount you can put on them is 5% of their body weight in the size of the collar.
What do you mean? Not what that part is. You could put 6% on there.
You could. Generally speaking, Cook doesn't like it when it's more than 5%, and it can be harmful to the animal. So generally, that's the number that's used.
It can also affect behavior.
Yeah, and so.
I mean, you don't walk as far when you have a heavy backpack on.
Right. So when we're doing locomotion stuff, we care about that value because of the way it affects the dynamics of movement.
Mm-hmm.
But if you're not studying that, and the animal has some other.
Well, you just want to know how far does it range, and it's got this weight on it. It's probably going to range. It's going to affect its behavior.
Right. So 6% versus 5%.
So why is 5% the magic number?
Are you invalid at 6%?
You could use 6%. I mean, I know people who have put tracking technology as much as 10% on an animal. Generally, you just want to minimize it as much as possible so that you're not inhibiting any of their behavior.
I didn't know if there's some other rationale in the literature.
No, it's really, that's just like the rule of thumb. For other species, they recommend even lower, closer to 2%. But yeah, otherwise, it's just kind of a random number they've thrown out from what it appears to be. So there are some trackers that are less than a gram, and so you can use these in order to track invertebrates or different birds or really small animals. Then you can have trackers that are weighing upwards of 5 to 10 kilos, which if you're tracking an elephant, size is not really an obstacle because you can put almost anything on a large animal. However, one of the hardest things with using tracking technology is being able to capture an animal. So sometimes that involves using nets, other times darting. So this is a darting rifle pictured below. And the challenge with that is you have to hit the animal at the right place. And it also is shot with such force that it can damage or possibly kill the animal if it hits them in the wrong location. A good alternative to a darting rifle is a blowgun, which is commonly used with primate species or other small animals. However, in order to use a blowgun, you have to be in very close proximity to the animal. So snares are commonly used. And so what they'll actually do, this is mostly for trapping large mammals, is they'll have a padded circle that's on the ground, and they'll bait an area. And so if they're trying to trap a leopard, you would hope that the leopard would step into it. It would tighten on their foot, and then you come back the next morning and you can then shoot the animal with a sedative. But snares are pretty good for a lot of animals. It doesn't harm them at all, especially because it's padded. And then lastly, you can use pitfall traps, which is pictured on the right, which is essentially where you dig a small hole and you're waiting for an animal to fall into that, and then it cannot get out. So this can be used a lot of times for herps, if you're trying to trap some sort of snake or reptile or even frog. So how do you dart or trap a moose? So a lot of large antelopes or ungulates are actually trapped via a helicopter. So what happens is there's a whole team in the helicopter that is chasing a herd of animals, and then you try and get a net around them or corral them, and then people actually jump out of the helicopter. But it's incredibly risky, and every year helicopters go down. So it's a really, really crazy thing to watch. Not very safe, but you can trap a lot of animals that way quickly. If you're trying to dart something like a giraffe, an issue that you have to think about is when you're darting them and they get sedated, that's a very large animal that's then going to fall on the ground. So with a lot of animals, you have to take many precautions when trapping them. When I work with primates, trapping them, you have to have about 10 people with nets so that once the animal's darted, that you can make sure you catch it as they fall from the tree. So now I'm going to segue into my particular project that I'm working on for my PhD. I study these lemurs down here. They're golden crowned fox, and they live in northern Madagascar. And what I'm interested in is looking at how their behavior and particularly their movements and social behavior are influenced by the type of forest that they live in, as well as the quality of that forest. So a little bit about Madagascar. Humans arrived only about 2,000 years ago. The population is growing at an extreme rate, and so every 25 years it has been doubling. And most of the species on the island are endemic, meaning that they're found nowhere else on Earth. And the only place that lemurs live is on this island. So I do my work in the far north of Madagascar. One thing that is unique about the lemurs I study is that unlike most species of lemur that are found in just one forest type, these lemurs are found in dry forest, rainforest, and a kind of moderate forest. So all of these dark green places are rainforest. The kind of medium bright green is a moderate deciduous forest, similar to the forest in Virginia. And then the two fragments that are more yellow in color are dry forest. And to give you perspective, from the main town Derina here to hike from here up to the top yellow one takes about a day and a half. So this is a very small area, smaller than the size of Montgomery County, is where this lemur species calls home. So characteristics of this species, they're critically endangered. They're folivorous, meaning that they eat primarily leaves. They live in groups of roughly 6 individuals is the median group size. And they occupy very variable home ranges, meaning that some groups have a really small area that they feed in, whereas other groups have quite a large group area. And they exhibit something called fission fusion. So fission fusion is this behavioral strategy that tons of different animals exhibit, and it's where sometimes they'll be together cohesive as a group, and other times the group will split into possibly 2, 3, 4 subgroups. And so these are different species that exhibit this behavior. It's common among many social species. Different lemurs, bison exhibit this, as well as many different cetacean species, such as dolphin and whales. So what I do for my work is I go into each of those forest fragments that I showed earlier, and I pick a group of lemurs that live in the center of the forest, and a group of lemurs that live on the edge of the forest. And everything I'm doing right now is based on that boots and binoculars approach, where I'm doing everything just watching the lemurs. And I'm recording data on where are they moving, what are they feeding on, so everything is done by hand. And two of the big things I'm recording are nearest neighbor, so that's the closest two lemurs together. So those two lemurs would be neighbors, and those two, whereas that dotted line represents what's called group spread, which is the longest distance between any two lemurs in a group. So what I'm hoping to do is to be able to do what I've been doing with boots and binoculars, but to do it with tracking collars, specifically proximity collars. One of the only known studies that's used these type of collars is with leopards and baboons. And so what they've done is they'll collar leopards in an area, and then they'll pick a baboon troop and collar as many individuals as they can. And so the collars all communicate with one another. So if there is a predator that comes near the baboons, then it can record what the baboons are doing. So if a leopard comes in, does the group come all together? Do they spread out and try and run away? So you can actually look at anti-predator behavior in a primate. So the collars that we're building with the help of Lucas back here are equipped with a GPS, a radio, a battery, a microcontroller, and an accelerometer as the 5 main components. And this is what they look like currently. This is not what they're going to look like when they're on the animal, but these are the components. And so I think, Lucas, you brought it with you?
I did not, unfortunately.
Okay. Well, if you have questions about the actual design, Lucas is happy to jump in. But so essentially what these collars would be doing is, so each lemur would have a collar and they would be assigned a node. So here we have nodes A, B, C, and D. And so every 5 minutes, we're programming the collars to be able to find the distance between A and B, A and C, A and D, and the same with all of them, so that we can get every combination of distance between the animals. And so we don't actually get a distance, we get a signal strength that comes from the collar, but in essence, we can build social networks from these lemurs to see who's spending time with whom, when they split and they have that fission fusion behavior. How far apart are they going? How long are the groups staying apart? So that's the next thing that we're working on, is deploying these hopefully on wild lemurs.
So, technical question: is there a reason why you're doing the calculations on chip rather than just doing the analysis post hoc?
So that's one thing that I did talk with the group. So one thing is that GPS, it currently has like 2 meter, roughly 2 meter accuracy, and we want to know the proximity of the 2 lemurs closer than 1 meter. And because of the as like GPS is not as accurate enough, we can actually just see the radios and look at the RSSI, which is signal strength, and then estimate what that would be. And then we found that to be more accurate than just relying on the GPS coordinates. Because sometimes there's there's foliage right there. Sometimes it doesn't get an accurate fix. Sometimes it can't see the satellites, etc. So we don't really rely on the GPS of its own. So that's why we're using the chip to chip communication and getting good strength out. I don't know if that answers your question, but
So how does that work?
so when
So
the
you just have 2 devices.
So like if there's 2 devices, so one radio would transmit, oh, this is let's say lemur 1, and it would just send the time and the date. And when the other lemur receives it, it actually gets the data and the RSSI, which is a signal strength. And based on the signal strength, you can actually estimate how far the 2 points were to the transmission. And we're relying on that data to be accurate enough to actually measure data. So I think the previous group before I worked, that worked on this before, they did do some rough measurements, and it was linear enough that you can actually say there was this much degradation between each decibel per meter, the RSSI value for a corresponding distance. So.
Yeah, and we just found, ideally it would be great if we could use just GPS to look at the distances. However, when there's really large cloud cover in the area, sometimes the GPS is only getting maybe 8 or 9 meters accuracy. And so we're trying to get on the level of a meter or less accuracy, which we're able to get using a radio as opposed to a GPS. So our goals for this device that we've been working on are, one, for it to be cost effective. So students and researchers that are trying to track wildlife, it's not really feasible to be purchasing $10,000 to $20,000, $3,000 tracking devices. So we've been able to make our devices for less than $100 a piece in components. So a drastic reduction in price. We want them to be reliable. That's our current issue. We want the radio to be functioning for a long period of time because of the difficulty in capturing animals. At least for the purpose of my study, I want the data to be salient to the questions I'm asking. So making sure that I'm getting at close proximity relationships, as well as using the GPS to look at the relationships when they split, and the groups could be hundreds of meters apart. We also, our collars are capable of remote retrieval of data. So using a computer, you can actually get fairly close to the lemurs and you can download data remotely without having to recover the collar from the animal. And we're also working on remote retrieval of the actual collar itself. So working on drop-off mechanisms so that way you don't have to go through the darting procedure more than once. So right now we're working on using motors that would then release. You could also do that with magnets. In a lot of cases like this collar, there's actually a small bit of gunpowder in the collar, and it's actually a chemical reaction that's triggered, and the collar is essentially blown off. It's not harmful to the animal at all because it's very, very little, but you can't do it in lemurs because they're too small of animals. Generally, it's done in larger mammals. And lastly, we want these collars to be open source by design. So we're not trying to patent anything. We're using all open source technology as is. So we're hoping to put everything on GitHub and have a repository for other researchers to be able to make their own collars if it comes to that, so that we can make this accessible to students and researchers, first at Virginia Tech, and then broaden our scope of where this is going. So currently, our next phase is going to be testing at the Duke Lemur Center. So Duke, located in Durham, North Carolina, has the largest collection of lemurs outside of Madagascar. And so once our collars are ready, we're going to be testing them on these lemurs. They have about 30 of the Shafak species located there, and so we can actually put them on captive lemurs that are the same size as the ones I study, to be able to make sure that the data collected is valid and that the collars are perfectly safe to be able to put on an animal in the wild. So just want to say thanks to Nicole and Ignacio, as well as Lucas and Haushen, who are the two undergrads working on this project right now, and the roughly 7 other undergrad engineers who have been working on this project over the last few years. Thanks, guys. If you have any questions.
So do you think there's enough work to do that we could actually devote a senior design project next year for mechanical engineers to design a new collar? Or?
So that's something that Nicole and I have talked about before, and I would really love that, if that could be a possibility.
It is. I mean, it's just a question of writing a one page and describing the project and then advertise it. I mean, we have more than 400 students, about 40 to 45 projects every year. So the professor in charge, she's always looking for more projects. This is interesting and challenging enough, to think that it would be a good senior design project.
Yeah, that would be wonderful to be able to have a group larger than 1 or 2 students being able to work on something like this.
I mean, we can organize with Nicole.
Okay.
Yeah, talk to Nicole. She's our engineer.
Right. Yeah, I'll talk to Nicole.
She just follows monkeys around.
Lemurs. Any more questions about the technology or the biology behind it?
So I think one of the big goals here is to make basically an affordable system that people can use, because you can imagine almost an infinite number of possibilities research-wise if you can make these things that are affordable and yet robust. You can always make it cheap, right? That they just break. But to make it cheap and robust such that people could use them
Yeah, I mean, you said $1,600,
$2,600.
$2,600.
Yeah.
That's
So
ridiculous.
And if you buy, usually you want a few of more than one, right? So
Yeah,
all of
I
a
would
sudden
say
it's
generally when people are studying, they have a sample size of at least 20 individuals. So, I mean, there's a faculty here at Tech that studies deer, and he'll purchase 40 to 50 collars at a time.
Oh, wow.
So, I mean, he's
real
spending
money.
over $120,000 on collars that
Yeah.
could be designed much more cheaply.
There's a question about, when you put the collar on a wild animal, they don't, I think it takes some time to get used to that, but how does it change your behavior?
So there's a guy in Montana who's done quite a bit of his research career on placing collars on wild dogs and being able to study the effect on their behavior. And he's found that really within 2 or 3 days of placing the collars, their behavior is completely fine, as well as their stress levels. So pretty much for any species, they don't mind it at all. And with lemurs, they may kind of pick at it for a couple hours, and then they almost forget that it's there. So for most animals, it doesn't change anything, luckily.
That's the key, is making it small enough.
Yeah.
And light
That's
enough.
what I was thinking about. I think there should be some limits on the weight that, this it's so light that after probably using it for a couple of days, they get used to that. It doesn't change the behavior. But
Well, the goal is 5%.
to 5%.
That you're trying to hit. Yeah, obviously the lighter and the smaller the better.
I think you mentioned, does the collar that you passed around, that had a battery life of a year? So
Yes, but a lot of these collars are remotely programmable. So, I mean, it really depends. So this collar, the study that's looking at foxes, we're looking at fox predation on a bird species in New York. So kind of in the winter, they program it to where they're only getting 5 to 10 GPS fixes a day. But then as soon as the chicks are born, they're able to program it to collect GPS data every 10 to 15. So it really just depends on the frequency. If you're collecting 10 to 12 GPS points per day, it can last for a year. But as soon as you increase the frequency, the battery life drastically drops off.
Well, great.
Thanks, guys.
Thank you.
Someone from Cadillac.
Yeah.
She's grad student at City Sponsors. So they have 20 of these. So I was like, oh, that's they're super expensive and nice.
Yeah.
Yes, you can send them back to the manufacturer.
So there's people that want to get the specific coordinates, but what
she's
she's really interested in is how the two lemurs interact. So the lemurs, they're touching each other, or floating or whatever, or they're laying down in some together. Yeah. And you want to see that, are these two lemurs actually interacting with each other? And if you get coordinates, they can be theoretically as far as 4 meters. But you want, they can be 4 meters apart. So that doesn't really mean much for her to what she wants to do. It's enough that you can say that they're actually I'm using Arduino and no, it doesn't. No. So contact. I was there. No, I would leave it basically. Just whatever you want to get the reading. So I have either students take my time, I have a son that's very well based on pretty much. I'll send you videos just a quick of the video. At the moment, I think 3 to 2. Yeah. So the funny thing is that this radio is $5, and the range is half a kilometer. So
It's pretty far.
Yeah.
It wouldn't be that far.
Exactly. So what I do is different range, energy level between